The magical world of electricity and magnetism. Ever wondered why a magnet sticks to your refrigerator, or how electronic devices work? Today we dive into the fascinating world of electricity and magnetism. What is electricity? Electricity is a physical phenomenon that results from the movement of charged particles, primarily electrons. There are two forms of electricity. Static electricity, in which charges accumulate on surfaces, and electric current, in which charges move through a conductor. The fundamental parameters of electricity are voltage, current, and resistance. Ohm's law describes the relationship between these parameters, with voltage being the potential difference, current being the movement of charges, and resistance being the amount of opposition in the conductor. Charge and electric field. Charge is a fundamental property of matter that is responsible for electrical interactions. Positive and negative charges attract each other, while like charges repel each other. An electric field is created around each charge and describes the forces acting on other charges in the vicinity. The electric field can be defined as the force per unit charge and is visualized by field lines radiating from positive charges and going to negative charges. The intensity of the electric field decreases with increasing distance from the source charge according to Coulomb's law. Electric current and potential. Electric current is the movement of free charges, usually electrons, through a conductor. Current, measured in amperes, indicates how much charge flows through the conductor per second. Electric potential, or voltage, refers to the potential energy per unit charge available to move the charge. A potential difference creates an electric current because charges move from an area of high potential to an area of low potential. Voltage is therefore a measure of the energy required to move charges within an electric field. What is magnetism? Magnetism is a physical phenomenon that results from the motion of charged particles, such as electrons. Every magnet has a north pole and a south pole, and the magnetic field that is created around the magnet can be represented by field lines that run from the North Pole to the South Pole. The Earth's magnetic field, which is created by convective flows of molten iron in the Earth's core, is responsible for the operation of compasses. The Lorentz force describes the interaction between moving charges and magnetic fields and forms the basis of many electromagnetic applications. A magnetic field. A magnetic field is the area around a magnet in which magnetic forces are exerted. The field lines indicate both the direction and the strength of the magnetic field. A current-carrying conductor also creates a magnetic field around itself, which is described by the Biot-Savart law. The underlying principle of electromagnetism is that electric currents can induce magnetic fields, and that changing magnetic fields can in turn induce electric currents. This principle is at the heart of many technological applications, such as electric motors, transformers, and generators. The power of electromagnets. An electromagnet is a magnet that only becomes magnetic when an electric current flows through the coil. The magnetic field that is created is proportional to the current and the number of turns of the coil. This allows us to adjust the strength of the magnet by regulating the current. Electromagnets form the basis of many devices, including electric motors, which convert electrical energy into mechanical energy, and transformers, which convert alternating current to another voltage. The concept of induction, as described by Faraday's law, is crucial to understanding how electromagnets work. Applications in daily life. The intimate relationship between electricity and magnetism, as described by Maxwell's laws, forms the basis for many of today's technologies. Electric motors convert electrical energy into mechanical energy by using the Lorentz force on a current-carrying conductor in a magnetic field. Even everyday appliances such as speakers and induction hobs are based on the principles of electromagnetic induction.